Welcome to Brain Vision.
So we're going to convert the revolution per minute values to essentially radians per second values. So omega initial would equal 130 RPMs, revolutions per minute, multiplied by 2 pi radians for every 1 revolution, or we can just say 2 pi radians for every revolution, and then multiply it by 1 minute for every 60 seconds. And this is giving us 13.6 radians per second. Omega final, the final angular velocity, 280 RPM. This would be multiplied by 2 pi radians per revolution, and then again 1 minute for every 60 seconds. This is giving us 29.3 radians per second. For part A, we want to find the angular acceleration. So the angular acceleration would be equal to the final angular velocity minus the initial angular velocity divided by t. This would equal 29.3 radians per second minus 13.6 radians per second divided by the time it takes to get to 29.3 radians per second, 4.0 seconds. This would be equal to 3.93 radians per second squared. For part B, we want to find, for part B, we should say, to find the components of the acceleration, we need to find the instantaneous angular velocity. So we can say that omega final would be equal to omega initial plus alpha t, the angular acceleration times time. This would be equal to 13.6 radians per second plus the angular acceleration found in part A, 3.93 radians per second squared, and this would be multiplied by 2.0 seconds. And we find that omega final would be equal to 21.5 radians per second. At this point, we can find the instantaneous radial acceleration. This would be equal to omega squared times the radius. So this would be 21.5 radians per second, quantity squared, multiplied by the radius of 0.35 meters. And this is giving us approximately 160 meters per second squared. We have to round to 2 significant figures. And then to find the tangential acceleration, we can say that the tangential acceleration would be equal to the angular acceleration multiplied by the radius. So this would be 3.93 radians per second squared, and this would be multiplied by 0.35 meters. This is giving us 1.4 meters per second squared. That is the end of the solution. Thank you for watching.